All right, hello everybody. Today we are going to be working on common logs. Okay, and our goal today is to solve exponential equations using common logs. Now, you guys have actually already seen an assignment with common logs on them. So we'll get there in a minute. Maybe you've already been asked about it by now. Our other goal for today is to evaluate log expressions, using change of base formula. So that's the formula that I told you during, I believe it was 8.5 notes, that eventually you'll learn how to evaluate any logarithm, depending, doesn't matter the base, but using your calculator to evaluate something like log base 4 of, I think it was 27 or something like that. Well, the ones we were working on. So now you're going to be able to use the change of base formula to say, oh, I can just plug that into my calculator and I'll know what the answer is. So that's what we're going to be working on today. So what is a common logarithm? A common logarithm is a base 10 logarithm. Okay. So for example, if I were to write out log 5, what this actually is log base 10 of 5. If there is no base, okay, when there's no base written, it's going to be 10. Okay, that's what it's the common log. So it's kind of like when we don't write an exponent, we assume that it's 1. When we don't write a base, we assume that it's 10. So finding common logs rounded to the nearest 10,000. So 4 decimal places. You should all be looking at a calculator, and on that calculator there should be a log button. And if you click log and then 7, you should get a log of 7. Log base 10 of 7 is approximately 0.8451. So that means 10 to this power would get you 7. Okay. Log base 10 of 0.6. So log of 0.6. Go ahead and type that in. And these are all approximate because you're going to be rounding a lot. And that's what happens with exponents and logs. We're going to be dealing with a lot of decimals, and we're not going to be able to convert them to fractions. But so this one is negative 0.2218. Looks like. Okay. So hopefully you're able to get those. Make sure you're rounding accurately. And if you need help finding a calculator with logarithms, let me know, because there are plenty of apps out there that you can download on your smartphones or using the internet in order to find those. So let me know if you need help with those. All right, so solving exponential equations using logarithms. So if you look at this equation, the way that we were doing it before would we say, okay, use your power chart and find 3 and 15 in the same row, and let's write 3 and 15 with the same base. And what would happen is, in this case, there's not a common base that you can write it with, so we're stuck. And you're actually not stuck, though, and that's how I'm going to show you what we're going to do. So in order to do this, what you can do is you can take a logarithm of both sides. That property of equality that we had talked about before says that if you took a common log, so log base 10 of 3 to the power of x, you can set that equal to log base 10 of 15. So it's kind of doing the opposite of what we were doing before. Before we were taking 3x, setting it equal to 15 because they were, the log was on the same on both sides. But in this case, we're going to do the opposite. We're actually taking a log on both sides. Now, the reason why we're doing this is because with that exponent, that can drop out front from that property that we learned in 8.5. So what this actually becomes is x times log base 10 of 3. Log of 3 is equal to log of 15. Now the reason why we did this is because since x was an exponent, you can now remove it from the exponent if it's within a logarithm, and you can bring it to multiply out front. So with that, now what we can do is x is almost alone, but it's being multiplied by log of 3. So we're going to divide by log of 3 on both sides, and that will go away on the left, and what we're left with is x equals log of 15 over the log of 3. So be careful when you type that into your calculator, though, because I want to make sure that you guys are typing it in the correct way. But you should get, if you're typing it in the correct way, 2.4650 is what you should get for x there. Now, this is super easy to check because look at your original problem. Okay, 3 to the power of x is equal to 15, right? You can do 3 to the power of 2.4650 and make sure it's really close to 15. Now remember, this is a rounded answer, so it's not going to probably come out as 15. It might come out as 14.99999 or 15.0001 or something along those lines. But as long as it's really close to 15, then you probably did it correct. So that is how you're going to do that. Now I'm going to give you the change of base formula, okay? Because actually you guys just pretty much derived the change of base formula. We just didn't realize we did it. So the change of base formula says that if you have log base a of n, okay, you can always evaluate this by taking the log. You can choose a base b of n over log base b of a. Okay. Now notice this b you get to choose, but the n is on top, the a is on the bottom. Okay, so from there, what we're going to do is we're going to go down to the next example. So this is the exact same example from the one up here. Okay, so notice these are the exact same problem. This one, what we did is we took the logarithm on both sides. The next way, it says in the directions to use converting and change of base to solve. So I'm going to show you how we're going to do this one. Okay. If I were to convert this, I'm going to have log base 3 of 15 is equal to x. All right. Now what you're going to do is you're going to use this change of base formula. Okay. I want to use a common log because that is what my calculator is able to do. So I'm going to use log base 10 on the top and the bottom. Okay. Technically, that should be on the left side. So remember the n was on top. So in this case, 15 replaces n, so 15 is on the top. The a was on the bottom, which was the base, so 3 is going to be on the bottom. Now in your calculator, you can type log of 15 divided by log of 3, which you'll notice this was a lot less steps than what we did up here, and we got the exact same thing, right? This was the same thing as what we got. We derived the change of base formula in that first one. That's all we did, was came up with it. So if, again, you type that into your calculator, we're going to get the same thing again. We're going to get that x is approximately 2.4650. And that's all I have for you today. So get used to using that change of base formula because it will change your life, let me tell you. In Unit 8 anyway. So if you have any questions, let me know. Other than that, that's what I have for you for today, and hope to talk to you guys soon.